Okay, so today we're on to 5.5, which is writing equations for proportional relationships. So last lesson, we were identifying whether relationships were proportional or not. And we looked at graphs, we looked at tables, and we looked at equations. This time, we're going to be looking at graphs and giving them an equation. And it's going to take us a couple steps to get there to be able to do that. Um, but by the end of this lesson, you'll be able to look at a graph and write the equation for it if it's a proportional relationship. So to start off, the first thing we need to know is the constant of proportionality. So the constant of proportionality is what the y value changes by for every increase in one of the x value. So for every time the x value increases by 1, that's what the y value increases by. And we've actually already been doing this. When we were testing the tables to see if they were proportional relationships or not, we were doing y divided by x and seeing what we came up with. So when you do y divided by x, you're finding the constant of proportionality. So just like what we were doing in tables, like when we would come up with 2/3 or whatever it was, that 2/3 would be the constant of proportionality. So now we're going to be doing that from graphs though. So the first thing you do when you're trying to figure out the constant of proportionality of a graph is you need to find a point where it's crossing at like two obvious places. So like here wouldn't be a good one because it's not obviously somewhere. So like this point, 1, 3 would be a good one. 2, 6 would be a good one. 3, 9 would be a good one. Any of those three is a good one to pick. It does not matter which one you pick because you're going to come up with the same thing. So this is the point 1, 3. We need to do y over x. So 3 over 1, which is 3. So the constant of proportionality of this graph is 3. You can also say for every pair of socks, it costs $3. I'm interpreting that based upon the labels on my graph. So the constant of proportionality here is 3. Same thing if I use this one to 6, I would get the same thing. Y over x equals 6 over 2, which is 3. And because it's a straight line crossing through 0, 0, we know they're all going to come up with the same thing. Okay, same here. One thing that trips people up is they're just going to go, okay, well, 3. But look here, when I find this crossing point, it's at 220. So the scale in which my graph is changing by is different. So I need to make sure I'm cognizant of that and paying attention to that. I could also pick this point for 40. And then same deal. I'm doing y over x. So my y coordinate is 20. My x coordinate is 2. So that gets us 10. So the constant of proportionality for this graph is 10. Or you can say for every minute, you'd use 10 gallons of whatever it is they're talking about. I didn't copy all of the wording that has to go with all the graphs because it took up too much space. And we really just need to know how to identify that constant of proportionality. So identifying the constant of proportionality is our first piece. So I want you to pause the video here and go work on IXL 7th grade K4. So K4 is just identifying the constant of proportionality. So it's finding the 3, it's finding the 10, it's finding the whatever it is for that specific graph. Okay, now that you're back, we are going to talk about writing the equation for proportional relationships now. So we talked about our equations for proportional relationships last class. Remember, it was y equals kx. Remember, and we said k could be anything. Well, what k is I'm going to highlight it. K represents the constant of proportionality. So you are now masters at finding the constant of proportionality because you just went and you practiced that a bunch of times. So the constant of proportionality now, once we figure out what that is, we can just chuck it into this equation. So it's going to be y equals whatever our constant of proportionality is, x. Okay, so I'm going to go back in time. Actually, I'm not. We're going to go forward in time. So we have to do exactly what we did here with finding our constant of proportionality. That's our first step. So I've got a point here that I'm going to use. So that point is 1, 5. I need to do y over x, which is 5 over 1. So it's 5. So my constant of proportionality is 5. Well, my equation for proportional relationships is y equals kx. In this case, 5 is k, so my equation is y equals 5x. All I'm doing is I'm taking that k out and I'm replacing it with what our constant of proportionality is. Okay, this one here, I can pick any point really. I'm going to pick that one. That one looks fun. It's the point 3, 3. So I need to do y over x, which is 3 over 3, which is 1. So in my y equals kx equation, I'm going to take the k out and replace it with 1. And technically, this works, but I don't even need to put the 1. So y equals x is also correct. This one is like the ideal way to write it, but this one will also be accepted. Okay, and I can go back in time and write equations for these two previous ones. For y equals kx, our constant of proportionality is 3, so it's y equals 3x. For y equals kx, our constant of proportionality is 10, so this equation is y equals 10x. Easy as that. So now to practice these ones, you're going to do IXL 7th grade K5. Okay, so K5 is writing your equations for proportional relationships.